Hello, everyone. Welcome to TMLS MLOps 2021. Thank you for joining us. Our speakers are Gulsen, Kutluoglu, and Sam Cohan. With a joint background in data science and engineering, Gulsen leads data product and AI ML efforts globally across Udemy, including the development of Udemy's catalog search, recommendations, knowledge graph, and personalization technologies, as well as ML platform. She has 15 plus years of experience in the field of software engineering and management, with a particular focus on ML applications and platforms for the last 7 plus years. She has more than 4 years of experience in the field of data science, including hands-on experience in search and recommendations data science. Prior to Udemy, Gulsen worked in various areas, including project management, full stack development, game development, and mobile applications. Sam Cohan is a principal machine learning engineer at Udemy. Sam's current focus at Udemy is enabling efficient workflows for building data products. Prior to joining Udemy, Sam was an early employee and founding team member at multiple data-heavy startups in the Bay Area, ranging from revenue intelligence to mobile advertising to crypto trading. Sam is a big believer in the power of building teams that can blur the lines between engineering and data science. Sam has a degree in computer engineering from the University of Waterloo and a master's in financial engineering from UC Berkeley. I encourage you to ask questions in the chat. I will be monitoring the chat throughout the talk, and we will leave time at the end for Q&A. Also, please take time to visit the booths and sign up for their nice prizes. And to help the organizers plan for future events, please take some time to answer the polls and the surveys. Enjoy the talk.
Okay, thank you. Thank you for the intro. Let's screen and let's start. I think all is fine. And you're able to see my screen. Okay, hello everyone, welcome. So this is Gulsen and I'm leading Data Products Group at Udemy. And today, Sam and I, we will be presenting you the challenges we faced and lessons we learned regarding ML operations during our tenure at Udemy. By the way, this presentation will take more than, I think slightly more than 35 minutes. But at the end, we will definitely leave some time for questions as well. 5 minutes, 10 minutes, I'm not sure. So please ask your questions and we will address them at the end. Okay, but let me start first with a very brief introduction for Udemy. Udemy is a marketplace, a global marketplace for teaching and learning. Anyone can introduce a course on our platform. And we are connecting these courses, in other words, instructors, with millions of students. These numbers you see on the screen in the slide is from December last year. So I think it's currently fair to say that we have more than 40 million users. We have more than 155K courses. And roughly speaking, we have more than 500 million course enrollments. I think this is a clear sign that we deal with big data. Okay, so Udemy has been experiencing a fast growth, especially in the recent years. Number of users increasing, number of courses increasing, enrollment count, consumption rates increasing. In other words, the data we use in our machine learning applications is growing. Okay. And this mainly brings us a challenge from architectural perspective. We need to come up with a more scalable platform. Another challenge the data growth introduces is it forces us to methodology we use while building machine learning applications. For instance, we need to consider distributed computing more since we deal with big data. And the company is growing. We are adding more people. Currently, we have more and more people who work on machine learning, who produce machine learning products. And at the same time, this increases product complexity from our perspective. In the very beginning years, we have 1 or 2 products, but now we have, I think, more than 30 machine learning products running in our production system. This is what I mean by increasing product complexity. And the growth in these areas is mainly challenging us from tooling and processes perspectives. For instance, we need to come up with better tooling, better tools, and better processes to improve the efficiency, because we have much more people at the time being, and we add more and more in time. And increase in product complexity, it introduces other challenges that we haven't tackled so far. For example, as I mentioned, we have more than 30 machine learning products in our production system currently, and we need to start considering their interaction with each other. For example, a model in search, how it interacts with another, a model that we use for personalized recommendations. And we need to also consider their impact on marketplace in the long run. So these are some of the outstanding questions we need to start tackling in the near future. But for today, we will try to summarize some of the learnings in these domains, some of the learnings we gained because of these challenges in these perspectives: architectural, tooling and processes, and organizational perspectives. I will start with architectural evolution, and then Sam will introduce tooling and process-related improvements. Some of them we did so far. And then I will wrap up with organizational changes very briefly. But before I start, let me note that what we are currently reflecting, talking about is mainly coming from machine learning product development experience. So we look at the process as a whole. So we, building the model and integrating that model to our production system is also a concern for us. But I'm pretty sure some of the lessons we mention here is applicable to the different parts of the different tracks in data science as well. Because I think some of the problems we are talking here are pretty universal problems in this ecosystem. Okay, so let me continue with architectural evolution. As I said, Udemy is growing, data is getting bigger and bigger, and even sometimes we see dramatic changes in data science. We see dramatic changes in data size within a very short period of time. And this is forcing us for a more scalable platform. But let me go back to the very beginning, to very initial times when we had 1 million users, for example. And the data size at those times, we had smaller data definitely, and training, we were able to train a simple model using our local environment. And we had a service in our production environment that we used to execute simple models like regressions or very basic tree-based models, let me say, in real time for every request. And this service was extracting feature values from MySQL. And I think the most important point here is that both feature computation and model execution, these processes were very lightweight. We were able to do these computations in real time without introducing any latency. Okay? But scaling up to 40 million users, in other words, dealing with big data, we definitely had to consider other approaches, other layers, technical stacks. For example, we had to move majority of our model execution and future computation pipelines to batch, because there is no way for us to do them in real time. It will introduce a lot of latency. It's impossible. And by the way, we still have some models that we execute in real time, and for which we do the feature computation in real time. For example, we do part of search ranking in real time. We have 2 models for search that we execute for every query. Or we have a tree-based personalized model for recommendations, for personalized ranking in recommendations. Again, we do the execution of this model in real time. But the point here is, again, both the feature extraction and model structure, they are simple and lightweight processes. So we are introducing no latency. And for the other cases where we have to respond in almost real time, we use streaming layers. We have a few features, for example, that we compute in almost real time, personalized features. For example, we collect the clicks from the users and we convert that information into some specified features for some of our personalized models. Or as another example, we have a banded system. We use banded system in some type of recommendations, and we collect our user events, process them, update banded, and refresh our recommendations in a few minutes. So we use streaming layer for these applications. And this is how our overall architecture looks like. As I said, batch processes, feature pipelines, modeling pipelines. There are a lot of pipelines we build, we use. I can say this is the main focus of the architecture for us. That's the layer. Batch layer is where we spend the most time, I think. And we use Hive, Spark. We work with ETL, Spark applications, or simple Python scripts sometimes in this layer. We have streaming applications. We use Spark streaming there. We do feature computations. We do model training, model executions in that layer too. We have multiple applications in the streaming layer. And we use data stores like Cassandra, Redis, Elasticsearch, MySQL as an interface between our offline processes or near real-time processes and online components. We have online components, like, as I mentioned before, we do real-time model execution for some use cases. Or for some specific domains, like search recommendations, we have dedicated or specific services. Search service, for example, a service that returns re-ranked search results through APIs. Okay, so this is the overall architecture at a very high level. And different teams are using different parts of this architecture. And at some point in time, I think it was last year or so, we realized that it's time for us to build generic components and increase reuse. Because as I said, we currently have multiple teams using different parts of the big picture I shared with you. For example, feature pipelines, modeling pipelines in data layer, definitely used by every team. Or model execution engine, that service that we use for real-time predictions is used by multiple teams, at least 2 teams. Or streaming layer, multiple teams, they are doing feature computation or they are training models in these layers. So we will either let everyone, individuals in teams, identify their own path, reinvent the wheel, make the development from scratch, and encounter the same problems again and again individually in silos, or we will build common components, generic components, and we will try to increase reuse between teams. And we decided to pick the other way for sure, but then the problem we had to consider was who will be responsible for these generic components, or let me say the platform in general. In the past, we had different teams. For example, search team be responsible for model execution engine, or we had recommendations team responsible for the generic modeling pipeline. Because building generic components and supporting the rest of the organization for these components is definitely a different scope. It is definitely different than machine learning product development scope, and that's how we came up with the idea of dedicated machine learning platform team. So we have been forming that team for a while, and hopefully this team will be responsible for our general platform, that generic platform, all the training and support related with that platform, so that the rest of the organization, other teams that focus on product development, machine learning product development, can utilize that platform and that generic component. Okay, so let me now leave. Let's stop sharing. Sam, maybe you can take over.
Awesome, thank you, Gulsen. Everybody, I hope everyone can see my screen. I think that's good. Okay, yeah. So my name is Sam Cohan, and I'm principal machine learning engineer here at Udemy. And I joined 1 year ago. Actually, yesterday was my 1-year anniversary. And so in the past year, my focus has been basically mostly on workflows, tools, and processes, which can help enable our great people deliver data products efficiently. So in the next 20 minutes, what I'd like to do is kind of set the stage up again in terms of the risk and challenges associated with explosive growth, and what we have done in terms of process and tooling to mitigate these risks and overcome the challenges. So as we've been saying, we've been growing quite significantly over the last year. In fact, this morning, I found out that over half of our employees now have a tenure of less than 1 year, which means they've never seen each other and they were never been to the same office. So I think that would be challenging at any point, even if we were going to the same office and seeing each other in person. But it's particularly challenging during a time where everyone's working remotely. So we have to be very careful, because if you don't have the right process and tooling in place, there are quite a few potential pitfalls. For example, all these smart folks come from different backgrounds, and if you don't have some established best practices to follow, and we give them a project, it's possible that they will not know about our preferences or our best practices, and they might reinvent the wheel or struggle, or might have like varying paces and qualities of a product delivery. Also, it makes for a steep learning curve, because if someone wants to take over a project, there isn't, or they just kind of get a lay of the code base. If there's not a unified approach, then it's going to be very hard for them to understand what's going on. This in turn also causes silos, because if people are like working on a project and just doing whatever they know how to do or their preference, then it's much harder to hand off that work to someone else, because there isn't a unified language that everyone speaks when it comes to understanding what's going on. So in solving these problems, we started to think about the entire workflow from development to production. And what we realized is probably this is a situation where we can improve the way things are here and address multiple pitfalls at once. So let's consider what the very common workflow is for most data organizations. Well, in most data organizations, the development and the production environments are two completely separate worlds. And by that, I don't necessarily mean segregation in terms of the environment, but I mean more in terms of the stakeholders, as well as the tooling and expectations on how to develop, and the priorities, I guess. So in a development environment, typically that's the data scientist domain, and most data scientists come from a scientific background. And while, they're of course expected to be able to code, but that's not the primary expectation from their role. So typically what would happen is, in a development environment, data scientists would work in a notebook. They will probably copy-paste a bunch of code from different places and write lots of ad hoc code. If they're very adamant about it, they might share those notebooks with some of their colleagues and put some of those into files. But ultimately, their main goal is to take a business problem and apply data and data techniques to it and solve that problem. So they're less concerned about what's going to happen in production. But of course, we all know, in order to get value out of any of that work, you need to have it in production and need to apply it to your business. So this is where the bottleneck layer happens. There's lots of effort required if you have that approach in the development and research phase. There's lots of effort required to get that into production. Typically, you'll have to completely rewrite in a different language, or at the very least, rewrite to have like a completely different structure that is appropriate to be in a production environment, where the things you care about are reliability and testability and maintainability. So with this in mind, the idea for efficiency we had was to try to close this gap between the development and production environments. Of course, this is much easier said than done because, yeah, if you try to impose too much process in the development environment and the research environment, then you risk alienating the folks that are trying to do their job there and making it too rigid and painful for their purpose. So this is definitely a balancing act. And what we realized that the approach has to address code quality in a way that is not just imposing process and imposing things on people, but rather to work with them and apply examples and reusable components to also make their life easier in their research work. And at the same time, get their code and the quality of the code they write closer to what would be more acceptable to go into the production environment eventually. In addition to this, the execution environments that are provided in this framework have unique benefits for research, which we'll talk about in the remainder of this presentation at some point. So with that in mind, let's go through the lessons we've learned so far and discuss these points one by one in more detail. Okay, so the first lesson that we learned is that you should standardize the development environment. So in the basically in the previous state of things, there was no development environment that was endorsed. We basically have some onboarding documents, and we leave it fairly open for folks to use whatever ID they want, set up on their local laptop or on a development machine. And typically, we would use shared notebooks for development. There wasn't really any opinionated way of doing things. And so this has a number of problems, right? So one problem is obviously the onboarding takes more time than it should. Now, this is a one-time cost, so maybe it's not that big a deal. But if you're thinking, you're hiring half of your people and each one is going to waste a week trying to just set up their laptop, that's not a great situation to be in. So you want a solution that will address that for sure. Secondly, if people are working on their local laptops, they'll probably end up working in silos and with code that's probably not checked in, especially if during development phase. And you don't really benefit from being able to see your colleagues' work and learn from them. Also, if they run into any issues, if each person is like following their own preferred development environment, then it's hard to help them, right? Because how do you know what to support, what not to support? The cost of support generally goes up. Also, of course, if you're on your laptop, it limits the type of work you can do. I mean, you can't do big data on a laptop, for example. And if you want to run that code then in a shared notebook environment, you're going to run into resource contention issues, and it could be problematic. Last but not least, if you're working on a local machine, it could be a security risk, right? It could be you don't want your organizational data to live on your team members' laptops, because if that laptop gets stolen, that could be a security breach or something that you don't want. So in order to address all these problems, we basically decided to standardize on development using Jupyter, cloud-based Jupyter notebooks as a development environment. So as opposed to having this document that says how to set up your local machine, we now have infrastructure as code. We use Terraform, but in some parts we also use CloudFormation to basically bring up a Jupyter instance that has pre-installed all the libraries and the code that our team needs to get started. So now, instead of wasting a week to set up your local machine, you simply enter someone's name into the system, and they get an instance that belongs to them, and they can use it straight away. This, of course, comes with some tooling to demonstrate how to use Jupyter as an IDE. For example, we make use of some magic functions to write the code in a cell into file, so it can be more modular. We plan to write more code formatting directly in the notebook, and of course, Jupyter is pretty nice for debugging, because you can just use PDB directly from inside it. So pretty much everything you would want from a hybrid development environment that's also interactive is present in Jupyter, and now it's the standard way which we try to promote for our team members to use. So the next learning is to standardize code structure and make use of reusable components. So yeah, again, in the previous state of things, we had some, still have actually some operators for ETL, which work well in the ETL realm because ETL is typically, if you can write some SQL scripts, that's probably good enough to do most types of ETL work. But we didn't really have any prescribed way of structuring a project or a common way of doing things. So the problem with this is, again, you end up in a world where you get diverging approaches to projects. And this is problematic because then you can't be really sure about the code quality. And it makes the learning curve steeper for people who need to be onboarded into different projects. Also, it's suboptimal, right? Because if people are coming in and they don't have a set way of doing things, they'll probably have to spend time to think about what the best approach is. And it's just like reinventing the wheel for no reason. And of course, it also, again, the whole silos problem is perpetuated here as well. So in the new state of the world, what we've done is we have a repository of example projects which make use of reusable components. So we thought about what are the most common use cases that we have in the types of things that we develop. And there are things like conversion rate modeling, clustering things, recommendations based on matrix factorization or other techniques. And now we have example projects that demonstrate what a project should have in terms of a complete project, that what the structure should be to deliver on these kinds of projects. So, and that's complemented with training materials that talk about what the code style is, what the best practices are, what the high-level design patterns are. So the combination of all these things has made it much more tractable for for people of various backgrounds to be able to deliver high-quality projects time and time after. Okay, so the next thing that's learning for us was to make use of ephemeral execution environments. So like many other companies, we started by having shared execution environments and shared dependencies. What typically this means is, for example, if you want to run a bunch of Spark apps, then you will probably have some sort of Spark cluster. Typically, if you're working in Amazon, it will be EMR, but it could be any other Spark cluster that you're managing. And everyone who wants to write a Spark app will use that particular cluster. I mean, you will probably have one for development, one for production, but either way, all your apps are going to run on one cluster or a number of clusters. So the problem with this approach is that typically there'll be a lot of shared dependencies. For example, if you're running a cluster with a specific Spark version, then you're stuck with that Spark version. If you want to upgrade the Spark version for a particular project, you either need to create a new cluster with an upgraded version and then manage how to route the different apps to different clusters, or you're going to have to upgrade every single app at the same time. Same problem typically will go for any other library upgrade versions. So it could be quite problematic and painful to handle. Also, note that if you're working with shared environments, then if you have one of the apps that is very resource intensive, that could cause a lot of resource contention issues. There are also other situations which are not easily supported by having this setup. For example, it's very common for data scientists to want to do very heavy backfilling type jobs or hyperparameter optimization jobs that are probably like on an ad hoc basis most of the time. And those types of jobs you can't really run on the same cluster that you're running currently. So you'll probably have to work closely with an infrastructure provisioning team internally, and you'll be basically dependent on them to be able to support you to put out such to have access to such resources. So in the new state of the world, what we've done is move completely to, well, not completely, but move as much as we can to ephemeral execution environments. And that is basically, instead of having a set execution environment, when you want to run a job remotely, you call a component that will provision a box on the fly, or a cluster even on the fly, and your work will run in there with its own dependencies, which you have defined in the opinionated project structure that we have defined. and you will not be dependent on any other project for running your code. So in this way, you can run your work in development with a set of dependencies that you are comfortable with and you are happy because you know they're up to date. And then when you go to production, you can be sure that the same code is going to get mirrored there and the same environment is going to be available, so there's going to be no nasty surprises. So the next learning is to have an explicit code review process and stick to it. Right, so I think most companies will have at least some sort of implicit code review process in mind. It's fine if you are not growing explosively, because if most of the people within the company know what the etiquette is and what everyone should follow, then probably when new people come, they'll get trained and they'll eventually pick it up. But even that situation is not ideal. In our situation, it could be much worse, right? Because if you suddenly half of your people are new, and it's very hard to transfer that knowledge and set the expectations. So this is one of those situations where it's more about process. In order to ensure that the code review process is consistent and the code quality, the bar is always met, we decided to codify very explicitly what the expectations are in terms of everything from how to use Git, how to have commits that are nice and understandable, to what is expected from the requestee, to what is expected of the reviewer, to how to discuss it. And this is not something new, but it's just if you're coming from a background where mostly a organic company that's just going from a growing phase to being a more established company, then it's something that you should be very aware of. Right, so next learning, testing is not optional. Yeah, so this sounds probably very obvious, especially if you're a developer. But I think in data organizations, testing is sometimes thought of as an afterthought or a nice to have. And it's more often than not the part of the project that's like cut short or not fully done in a rigorously. Because if you're rushing to deliver a project, then you'll probably skimp on having nice tests. This is very problematic because, well, one, if you ever need to make changes to the project later, then it's going to be a very painful process, because you don't know if even if you're making a very simple change, is this going to break things or not? I don't know. And then it generally makes a culture where people will be more reluctant to make changes, improvements to code, because technical debt will accrue, because every time I'm going to make a change, I have to think twice about, well, if I make this small change and I have to do a bunch of manual testing and then I'll risk breaking things, is it really worth my time? So in the new world, we've made testing mandatory, and we have much more emphasis on testing and checking code coverage and making sure that a project doesn't just go live without having tests that are appropriate and going to give us some confidence that if we need to make changes later, we're not going to break things. Okay, and yeah, this last learning, post-release monitoring is not optional. So again, this is one of those things that is probably obvious to a lot of you. What I would say is most companies think post-release monitoring is just putting a bunch of alerts in place and then managing them as it happens. But if you're not careful, you'll end up in a situation where you get a lot of spam alerts coming in, and especially when you have a growing team, they don't really know what to ignore and what not to ignore. So they'll probably end up like filtering away lots of older alerts, basically. And that combined with an implicit shared responsibility on looking out for issues with these alerts can be a recipe for disaster, because things can fall through the cracks, and you could end up in situations where something breaks and you don't find out until much later. So in the new state of the world, this is a situation where we had to both change some technical stuff and also to change process. So on a technical front, we spent some time to decide what alerts are important and make sure that those are routed to a Slack channel that's for support and is going to get monitored by all the team members, and it doesn't spam too much, more importantly. And we codified, what is important to go into that, into those alerts, and what to do about them if something goes wrong. On top, we made an explicit on-call schedule and process for documenting issues and learning from them. So going forward, if something goes wrong, there's one person that's going to be responsible for it, to know that this is, you can be confident that during your schedule, you're going to be sure to look at any problems that come up and fix them so they don't go unnoticed. Cool. So finally, I just want to talk a little bit about some practical challenges with doing all this work. Yeah, so I think probably the most difficult thing about all of this is that, in trying to bridge that gap between development and production, it's really hard to know. It's really hard to know what the right level of abstraction is and how much opinionated you need to be, because it's you're trying to solve really hard problems and a diverse set of problems. So if you have something that's super opinionated and very burdensome, then it's gonna be getting in the way of actually getting work done. And if you have something that's very broad, then you're going to end up in a situation again where you're leaving too much to interpretation. If you leave too much to interpretation, then you'll have diverging approaches again, and it'll be problematic. And it's not always even clear what best practice should be in the first place. But what I think is important here is to spend the time ahead of time and make these decisions as a team, and then enact them and stick to them and iterate on them if need be. Having this deliberate approach is much better than leaving things to chance and then hoping for the best. The second thing I would say is this whole, taking all these reusable components and making sure everyone's doing the same thing, it could be great, because if you make a small change, it can potentially basically everyone can benefit from it, right? But if there are bugs or if there are issues, then that also cuts both ways, right? Everyone will be affected. Another thing to keep in mind is adoption, right? And none of this matters if it's not adopted, right? And as someone going new into a company and you're trying to drive some change, organizational change and process change and tool change, it's important to have buy-in from all the main stakeholders. And specifically, this might be a little bit easier actually for new employees, because they're going into a new environment and they're probably going to accept the approaches that you put in front of them. But I think it might be a little bit harder to convince existing employees why this makes sense to change the approach that they've been taking in the past. And in order to overcome this challenge, we make sure to partner early with our stakeholders and have discussions and show them how the new approaches can help them deliver on a project that they are trying to deliver. So this has really helped a lot, because when someone is trying to take care of a project and they're running short on time, they of course welcome the help of someone coming in and trying to show them some ways that make use of reusable components and existing structures that have some benefits. So yeah, that's been a great approach there. And then finally, I just want to say, dealing with open source and third-party solutions can be challenging. A great example of this is we're making use of some specific SageMaker instances, some SageMaker components called scikit-learn processor and PySpark processor. And well, these components are great for what they do, but of course, they could use improvement, and they have some sharp corners which need to be worked out. And they're not open source. If it was open source, we probably would make the change ourselves. But we have to make sure to build the right relationships with AWS and with Amazon and with whatever vendor it is that providing that solution, to make sure that we can use it for the purposes that we have in mind. Okay, that is my part. I'm going to hand it back to Gulsen.
Thank you, Sam. Okay. Let me continue with, you see my screen, right? So please say no if not. Okay, so let me continue very briefly with organizational challenges, and I will wrap up. So we talk about architectural changes, we talk about tools and processes related changes, and let's now briefly talk about people. As we mentioned, the company is growing and we are adding more and more people, and one of the questions, one of the problems we had to spend time on was what is the right structure here? And we learned that data science, having data science and engineering closely collaborating is very, very important to build complex machine learning systems. In the past, we had separate teams, separate engineering and data science teams, and there was a lot of back and forth between those teams to even realize a simple project. And we had to align multiple things. We had to align priorities of different teams. We had to align plans quarterly or even weekly per sprint plans for each teams to be able to have engineers and data scientists work together. But then we started building cross-functional teams, put software engineers, machine learning engineers, and data scientists into the same teams, and have them focus building, working towards the same goal, focus building the product together. And that definitely was created more efficiency, created, improved the quality of the work, the ultimate product, also decreased the implementation time or development time as well. And the other thing we learned in time is using Agile, Scrum in particular to our case, improved the efficiency, let me say, of the machine learning development lifecycle. I know there is a lot of discussion on this, and probably call it even a debate on this, whether or not to apply Scrum, for instance, to data science, but we do. We use let me say, a lightweight version of Scrum, and it helps us. It helps us to handle unknowns in the machine learning development lifecycle in a much more effective way. It helps us to stay focused. Focus delivering MVP instead of getting lost with hard problems, questions. Also, we make use of concepts like incrementality, iterations, time boxing. So definitely it helps us, Agile or Scrum in particular, helps us to apply, to experience better processes. But let me stop here. We can talk about, maybe hours on this topic, but let me stop here. Let me just share this one as a final short note. And let me wrap up. Yeah, so we still have a long journey ahead of us. In a few quarters, maybe we will make dramatic changes in our platform, in the big picture I presented to you. Or we already have some planned improvements, tools and processes related improvements. So definitely there are more things for us to do, to explore, and hopefully we will share this with the community as we make progress, as we learn in the future. Okay, so let me stop here and let us start answering questions. I think I also saw a few questions. There are good questions, so let's focus on questions right now.
Yeah, there's quite a few questions. Thank you so much, Gulsen and Sam. That's quite a lot to get your head around. So there's a few questions about the handoff between the teams, and is there a ML ops team specifically taking care of the models in production? When is the handover to them? Is there involvement from this team in code review, testing, and so on? And is there a handoff between the data scientists and the ops engineers? And how does this work in the Agile framework? You've touched on some of this, but
yeah, Sam, would you like to? But you go ahead first, and then I will add. Yeah.
Sure. Yeah. Yeah, this is a very good question. Our ops team is mostly going to be working on platform and creating these reusable components. So they won't actually be responsible for anything in production. The idea here is that they will work with data scientists to make sure that they use the components in the right way and they follow the right methodologies and get their code, help them get the code in the right state. But ultimately, the team, I would say, that develops the solution is going to be responsible for making sure that it's running in production smoothly and it's going to get updated in a way that makes sense. So in this way, there's never like really a handoff. It's more kind of consulting services and tools and reusable components that are helped with. And then the team that puts that solution out is collectively responsible through their schedule, on-call schedule, and everything else to make sure that it's running smoothly in production.
Yeah, I agree. I mean, the key point here is our ML platform team will be building core components and tools and processes, and the rest of the teams, data scientists and engineers, will be using them. Here, we will have the team to enable others instead of working with them directly to productionize their solutions. But there are a few cases, there might be a few cases where this is not possible. For example, there might be very engineering-heavy cases, engineering-heavy products like recently we encountered Bandit project. There, we were building something from scratch, and both data science and engineering effort was needed. For such cases, we have engineers on our teams, product development teams, like I presented in our very last slide. And we expect these engineers to jump in and work closely with data scientists to realize it. And once, I think this is also an important point, once a team builds and develops a solution and brings it to some point, and then another team wants to use that solution, then we will be giving that solution to ML platform team to make it generic and make it part of the platform. That's the mechanism we currently use between the teams and how we position the ML platform team and MLOps in the future.
So there's a couple of questions here. Armand asks, what are your thoughts on pre-built images that you can simply mount on a VM EC2 instance? Did you try it? And are there any advantages to your current approach? And I would say a similar question, Ramton asks, how do you reconcile the ephemeral execution environments with reproducible and reused shared components?
Yeah, that's a good question. I think there are two actually very separate questions. For the first part, I would say, yes, what we tried is actually with a lot of SageMaker components, you can actually create your own Docker instance and put it on ECR, which is like the Amazon Elastic something, I forget the name. But anyways, ECR is basically the equivalent of having these images that you can just load onto a machine. So you can do that within our framework as well, but PySpark processor basically gives you a box that comes with scikit-learn installed and a lot of other stuff installed already, and then we have scripts that install our stuff on top of it. So it's less worrying about having to manage these containers over time, because we're just getting this base thing that has all the stuff that you want, and then we have written some specific deployment scripts that will install our code and our libraries on top of it. So it's just less things to maintain. But both approaches are valid. And if we ever want to do stuff that's more complicated or install things that'll take a longer time, then we'll probably just use ECR. We'll use some sort of containers that are much more custom. As for the second question, in terms of reconciling, sorry, let me just remember the question.
How do you reconcile ephemeral execution environments with reproducible and reusable shared components?
Yeah, so this is actually very challenging because shared components, when you want to test them, there's basically, they might have slightly different behaviors on different library versions or different environments. So our ephemeral environments are built in a way that you get a base image and then you install additional stuff on top and then you run your code. So when it comes to testing, we typically try to have several versions that are tested, but it's not going to be exhaustive. So each project will be responsible for making sure that the behavior of the behavior of the test and the component that they're using within their specific project is going to be fine with that library version. So so it's basically making sure that the shared components can run on different library versions with the same results. That's how you reconcile it.
I'll ask a couple more questions here. Can you please share your experience using Agile using Agile, I guess, for ML development, especially around data science work?
Yeah, maybe I can respond to this one. Okay, so let me start with the development cycle. Let me start with a broader view. ML product development cycle. So we also work with product managers. Product manager usually brings us a user problem, and then we convert that user problem into a machine learning problem. And then we came up with some solutions. We do literature review. Then we select a few solutions, and then we prototype those solutions, and then we do offline evaluation, and then we productionize the solution as soon as we have a good output, an output that is promising, that looks promising during offline evaluation. And then we productionize, and then we do A/B test, and according to the A/B test results, there can be some iteration as well. Our definition of success is tightly coupled with, usually A/B tests. That's the overall, at a very high level, that's the development life cycle. We apply, we follow, let me say, for especially new projects, okay? And so depending on where you are in that life cycle, by the way, let me also add this, we use 2-week sprints. We do daily stand-ups, and we do, before sprint planning, we do grooming. We do sprint planning and retrospective as well. For example, every planning, grooming, and planning in every 2 weeks helps us to realize where we are here in this cycle, where we are, where we want to go, and what we need to do more, etc. So that's what I mean by staying focused. In the past, usually the models we build, the problems we deal with are very complex. So there's a high chance that a single person, and if they are working in a siloed way, probably they will get lost. But this way, it keeps us focused, on the path. Every day we do daily stand-ups, and we know what kind of dependencies, and more importantly, what kind of blockers a data scientist can have. Anything can be a blocker. Waiting for a code review can be a blocker. Scalability issues can be a blocker. Data quality issues can be a blocker. With Scrum and daily stand-ups, we have visibility into those issues, so that the team, for example, engineers on the team can jump in, or other data scientists on the team can jump in and help. And also involvement, one final thing. There are a few more things in my mind, but let me just mention this one final thing. Having product owner, product manager, someone wearing a different hat, someone focusing on the delivery, the ultimate goal, priorities, really helps us to make definition of success and clearly define the scope for that machine learning product. As I said, it is hard. For example, assume that we are building a relevance model for search. So what is relevance? How do you define relevance? What is your success metric here? Will blah blah metric, having 99% for that blah blah metric will be fine. So we need other minds, having other minds, others responsible for thinking about definition of success, dealing with or integrating our position into the overall product vision, etc. It really helps. And having product manager, of course, in this process, in grooming, in planning, etc., really helps us to stay focused, clarify the scope, clarify definition of success in a proper way. Yeah, so I can talk about this for hours, so let me stop here. But we definitely have such advantages, let me say.
I'll ask one more question because people are dropping off, but there's a question around the costs of having a Jupyter Notebook instance for every data scientist. maybe you could speak about that. And specifically, they mentioned idle instances.
Yeah, for sure. So it's very easy to add like a life cycle thing to Jupyter instances that if they're idle, it'll shut itself down so you don't end up paying for it. So we have that set up. We had it at 2 hours to shut down. Now we have it at more like 5 hours so people won't get annoyed, because you don't want it like to shut down in the middle of the day as if they're going to lunch, an extended lunch or something. So yeah, I mean, there's definitely some inefficiency, but overall, I think by default, we use the smallest instance. It's like 5 cents an hour. It's not a big cost compared to the human cost of having those be available and not running into each other. So overall, yeah, there's ways you can mitigate it, and if people need to work on a project where they need a bigger instance, then we ask them to be more cognizant of the cost and try to not leave it running for long periods of time if they're not using it. So yeah, it's one of those things where you just try to mitigate as much as possible, and is ultimately worth it.
Amazing. Yeah, that's fantastic. We've run way over time, but thank you so much. Appreciate all of your insights and sharing of all of your lessons learned, and it's really interesting. Thank you.
Thank you very much.
Thank you very much. Please reach out to us if you have more questions. Okay. Thank you very much, Marlene. Bye.
Thanks.
Take care.